Okay, problem 96, if you read through it, it's just a word problem, but in the end, it wants to know, like, what is the area of this cone? So you just need the area of the cone formula, which is 1/3 base times height. And B stands for the area of the base, which is a circle, pi r squared, h being the height. What you don't have is the r, which would be right here, the radius, right? So you do need the Pythagorean theorem to find A, or the radius, excuse me, call it A. So r squared plus 20 squared equals 25 squared. So let's calculate r right now. So I get r of 15. Okay, so that's the radius of the cone. So we're going to go ahead and put that in for the radius of the cone. 15 squared times the height is 20 of this cone, and the third, sorry, we already have the pi there. Okay, so do a little bit of calculating. 15 squared is 225 times 20 times the third times pi. And let's see what we got here. So at this point, I now realize that I didn't read the question correctly, because it says, what is the area of the circular region that he can explore? That's just a circle, pi times r squared. I spent all that time trying to figure out the cone, and it didn't really matter. There is no cone. It just wants to explore the floor. So that's 15 squared times pi. That's 225 pi, and that is the answer. Okay, number 97. Write out the distance formula using these letters. Distance equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's it for 97. That's the formula. Determine whether this triangle with these vertices is equilateral, isosceles, or right. So the first thing you should do is probably plot them just so you get a rough idea. And then we're going to have to find the distances of all the sides. So we're going to use the formula from the previous page. You can take a minute, pause the video, and just kind of do some of the work. Okay, so I've sketched it, and I've copied the formula from the previous problem. And now I'm ready to find the distance of AB. You can do this by using the coordinates of AB. So you need the difference of the x's squared plus the difference of the y's squared. So the difference of the x's is 11 minus 3, which is 8 squared. And the difference of the y's would be 3 minus 5, which is negative 2 squared is positive 4. 64. So that ends up being a square root of 68. Okay? So now we just need to do something similar with the other sides, like let's say BC. That's the distance of BC. Let's find the difference of the x's squared, difference of the y's squared. Okay, so we need to see the difference in the x's. From 11 to 8, it's a difference of 3. 3 to 8 is a difference of 5. 9 plus 25 is 34. Okay, so those two sides are the same. Now let's get that last side, which is AC. A to C, okay, A to C to compare these. So 8 to 3 is a difference of 5 squared plus 5 to 8 is a difference of 3 squared. So that's 25 plus 9, that's square root of 34 also. So my answer, I think, is going to be isosceles triangle. Because 34 and 34 are the two same sides and the side that's different. So it's an isosceles right triangle is the only option you have there. Okay, now it says find the distances of each point, how far they are from the origin. And I think the easiest way to do this is simply plot it. I'm not going to actually use distance formula in this problem. So let's plot all these points. 5, 0, 1, 2, 3, 4, 5. So that's 3, 4, 1, 2, 3, 4. Okay. So the first one's easy. How far away is it from the origin? Well, that's 5. The second one is a little bit harder, but not really, because it went over 3 and up 4, and so the distance is 5. It's a 3, 4, 5 triangle. All of these are going to end up being the same. Back 4, up 3. That's a 3, 4, 5 triangle. So its distance is 5. Negative 5 is 0. That's 5 away. Negative 3, negative 4. That's 5 away from the origin. And 0 and 5. That's 5 away. If you make a continuous curve, you end up with a circle. This probably won't be a very good circle, but all of those points lie on a circle. So let's go to problem 100. How do you make the equation of a circle that has a radius of 5? Well, if it's centered at the origin, you do x squared plus y squared equals r squared, and r is 5. So that's 25. So this is the equation of the circle.